Today, let us look at conversion of solids. When a solid or a combination of solids is melted or reshaped to form another shape, we call that conversion of solids. Let us take an example of a cylinder. If the cylinder was made of clay and we simply reshaped it to form a cone, then the volume of this solid would stay the same, or the volume of the cylinder would be equal to the volume of the cone formed this way. Let us look at these four spheres. We could put them together and reshape them to form a cuboid. Note that the volume of the solid would stay the same. There's another type of conversion of solids when it is cut or broken to form another shape. Let us take the example of a cone. If we take a plane and cut the cone parallel to its base with the help of this plane, then we would be breaking the bigger cone into a smaller cone and another shape which is called the frustum of this cone. There is something interesting about the right triangles which are forming these shapes. The right triangle from the bigger cone and the right triangle from the smaller cone, since they have the same vertical angle and both of them have a right angle, these two triangles would be similar. If the height and radius of the smaller cone was small h and small r, and the height and radius of the bigger cone was capital H and capital R, then, due to the similarity of these two triangles, the ratio of their sides would also be proportional. So, capital H by capital R would be equal to small h by small r. Let us look at a problem. A water tank in the shape of a hemisphere is emptied at the rate of 4 liters per second. How much time will it take to empty the tank if it is 3.5 meters in diameter? Let us draw the diagram first. It's a hemisphere whose radius is 3.5 by 2 meters. Now we are going to empty the tank, which means we are dealing with the volume of this tank. Since the shape is a hemisphere, the volume of tank would be equal to volume of this hemisphere, which is 2 upon 3 times pi r cube. We are also given that it is being emptied at the rate of 4 liters per second. Let us convert liters into meter cube. We know that 1 meter cube is equal to 1000 liters. So 4 liters would be equal to 4 by 1000 meter cube. Alright, now the volume of tank would also be equal to the rate of emptying multiplied by the time taken. Recall that the rate of emptying is per second. So my time taken would be in seconds. Let us substitute the values and cross multiply to find the time taken, or T. Let us simplify and calculate. We find that T is equal to 401 seconds. Let us look at another problem. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. The ice cream is to be filled into cones of height 4 cm and diameter 6 cm, having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. So we are given a right circular cylinder and its dimensions. The radius is 6 cm and the height is 15 cm. Now we are also given a cone of height 4 cm and radius 3 cm, which has a hemispherical shape on the top. The radius of this hemisphere would also be 3 cm. Now we must note that the volume of ice cream is going to stay the same. So the volume of ice cream in the cylinder would be equal to the volume of ice cream in special cones. We could also write that as n times volume of one special cone, where n is the number of special cones. Let us substitute the formulae. On the left, we would have pi times capital R square times capital H. On the right hand side, we would have n times volume of cone plus volume of hemisphere, or n times 1 upon 3 times pi r square h plus 2 upon 3 times pi r cube. We can take pi r square by 3 common and have h plus 2r in a bracket. Let us divide both the sides by pi. Let us cross multiply and substitute the values. We find that n is equal to 18, so we can fill 18 such special cones with ice cream. Let us look at another problem. A metallic right circular cone 20 centimeters high and whose vertical angle is 60 degrees is cut into two parts at the middle of its height by a plane parallel to its base. If the frustum so obtained be drawn into a wire of diameter 1 by 16 centimeters, find the length of the wire. We are given a cone and we are cutting it with a plane. So we get a smaller cone and a frustum of the cone. Now this frustum, please note, only the frustum is drawn into a wire. Alright, now let us draw the right triangles representing the bigger and smaller cones. Now we are given the vertical angle as 60 degrees. So half of the vertical angle would be 30 degrees, which would be the top angle of this right triangle, or the top angle of the right triangles, since the smaller triangle is cut from the bigger triangle. We are also given the height of the bigger cone as 20 centimeters. Since the bigger cone was cut at the middle of its height, the height of the smaller cone would be 10 centimeters. We are also given the diameter of the wire, so we can find the radius as half of the diameter, which gives us 1 by 32 centimeters. Now, the frustum is drawn into a wire, so the volume of these solids shall stay the same. So, volume of frustum is equal to volume of wire. How do we find the volume of this frustum? We know the formula for volume of a cone. So, volume of original cone minus volume of smaller cone would give me the volume of frustum. Let us substitute the formulae. We have 1 upon 3 times pi times capital R square times capital H as volume of original cone, and 1 upon 3 times pi times R square H as volume of smaller cone. The volume of the wire would be pi R dash square times L. Since the wire is in the form of a cylinder, we are representing the height of the wire as L. Let us divide both sides by pi and multiply both sides by 3. Now we are given small h, capital H and R dash. We do not know small r, capital R and L. Is there a way that we can find small r and capital R? Recall from trigonometry that tan of an angle is equal to the side opposite the angle divided by the side adjacent to the angle, or tan theta is equal to perpendicular by base. Now here we have tan 30. So in the smaller triangle, tan 30 would be small r by small h, and in the bigger triangle, tan 30 would be equal to capital R divided by capital H. Upon cross multiplying, we find that small r is equal to h times tan 30 and capital R is equal to capital H times tan 30. We can substitute the values of small r and capital R in terms of small h and capital H. Let us simplify our equation and substitute the values and solve for L. Now L comes as a huge number in centimeters, so we can convert it into meters. You could also convert this into kilometers.